From now on, I will explain the introduction of OpenCV. OpenCV is a computer vision library consisting of more than 2000 algorithms. Among them, there are general image processing functions and segmentation to cut off the object from the background, and the geometric descriptor to express any object shape. The various transform functions, and as you can see here, there is a function that extracts the straight line features, and the machine learning function have been included these days. Thus, OpenCV can detect the face and recognize the person. Next, there is a tracking that follows a person's face and or a specific body part, and provides various functions of matrix calculations. An image pyramid uses multi-level precision images in the form of a pyramid to describe an object. When the object is seen by far, the lower resolution image is used. When it gets closer and closer, the higher resolution images are used. There are camera calibration functions, stereo cameras, 3D functions, and the data structure and fittings. There are so many algorithms in the OpenCV, and you can visit OpenCV homepage, and you can get some detailed information about that. OpenCV is fast enough for real-time application. Here is a graph comparing the performance of several computer vision library. The performance of a computer vision library called LTI and the VXL are compared with that of OpenCV and OpenCV plus IPP. IPP means Intel Performance Primitives, and it is a library that speeds up the performance of a computer equipped with an Intel CPU. When the forward transformation and resize and optical flow and neural network are performed, and the OpenCV shows a very good performance, especially with use with IPP. So I think this is a second time. So OpenCV shows very short times to perform these functions. OpenCV is used in many areas such as Google Map and Google Street View, Google Earth and Google Books, and academic and industry research, safety monitoring such as dam site and mine and the swimming pool, and security systems, image retrieval and the video search, structure from motion in movie, machine vision for inspection system of the factory, the robotics, etc. This image is detecting road from the images from the camera, and it can be used to drive unmanned car driving system. OpenCV provides a main module and more extra modules. Main module includes core functionality. It's a name of the module, core, and the image processing, and the image file reading and writing, image codecs, video I/O, high level GUI, that is a graphic user interface, and the video analysis, camera calibration and the 3D reconstruction, Calib 3D, 2D feature framework, features 2D, the object detection, object detect, deep neural network module, it's a DNN, machine learning is a ML, the clustering and the search in multidimensional space, it is FLANN, computational photography is the name of module is photo, image stitching means it's bind the image into one, and graphic API. So these are main module, and there are lots of hundreds of extra module in the OpenCV, and please visit docs.opencv.org/4.2. This is the latest version of OpenCV, so you can find the module that you are interested in. OpenCV can be run on Linux and the Windows system and the Mac OS. Recently, Android is included since OpenCV 2.2. So OpenCV can be run on wide range of the operating system. And also the language that OpenCV support is C++ and Python and C. So Python is recently gaining population, and in our lecture, so we will use C++. And you can find reference and manuals in online. When you visit opencv.org, then you can find the online documentation. In detecting edge in the image, OpenCV does not use the traditional 3x3 gradient finder called Sobel. Sobel was the most popular gradient finder in computer vision area, but instead OpenCV used the 3x3 scar operator instead, since it is just as fast as a Sobel, but it has a more accurate response on diagonals. So scar subroutine is here, and this is a result of a scar operator. So by extracting the edges of the object like this, then we will the extracting edge is the first step for the segmentation or recognition. So reliable edge detection is very important in computer vision stuff. So OpenCV uses scar gradient edge detector. You can use Canny edge detector in OpenCV. Canny edge detector is another very famous edge detector. So the algorithm was invented by Canny, and the OpenCV include that Canny edge detectors. The half transform can detect a feature such as a circle and a straight line from the input image. Images on the right are straight lines detected from the left image using half transform. So when you use a half a circle here, you may find out the circle features like this. And if you use a half lines or half lines P, so you can extract all the straight line. So this is a straight line, and these are straight lines here. Okay. So straight line and circle is a very strong feature that represent some object. Scale space is a framework for multi-scale signal representation. If you have a flower-like image like this, you may want to express it in a lower resolution picture when you look at it from a distance. Therefore, there are times when it is necessary to create image that represent the same object but with different resolution. Keep them in one data structure. Pyramid in Egypt look like this. Pyramid in Egypt is wider at the bottom and narrower as it goes upward. So in the same sense, the pyramid in computer vision field is a multi-level image from large resolution to small resolution. So there is a image with large resolution, image with a smaller and smaller resolution. In OpenCV, you can increase or decrease the resolution of the image through the subroutine pyramid down or pyramid up. These are subroutine that OpenCV provide you. So when you look at this flower at distance, this is flower, that you use this low resolution image, and you are moving closer and closer, you will have the higher resolution. OpenCV provides a log polar transformation function. The picture on the right is a result of log polar transformation of the deer picture on the left. Log polar transform converts image of a Cartesian coordinate system into the image expressed in the log r and angle measured around the specific center. From center to here, the image is from here to here, and as the angle increases, the radius become increased. This corner is here. Then from here to here, radius decrease, and here there are another peak here, and this is the nearest point here, from here to here. Then this corner and this corner is corresponding to this and this. So this is angle, this axis is angle, and this is log r. So by rotating at the center of the box here, rotating this r for 360 degree, there will be 4 peaks here, 1 2 3 4, and valleys, 4 valleys here, 1 2 3 4. When the image is rotated like this, from black box to the red dot box, the theta shifted for 45 degree like this from here to here, and when the size is become bigger, the log r is shifted like this. When we have a point cloud consisting of many 3D points, we can create meshes by Delaunay triangulation provided by OpenCV. These are point clouds, lots of points. These points data can be obtained from 3D scanner. Then we can generate these meshes using Delaunay triangulation or Brownoy tessellation. So we can use this subroutine CV create subdivide the Delaunay 2D. Contour of an object can be extracted by using find contour subroutine. So we can have several contour of several segments. Then we will merge them, and finally we will get the final contour of the cat. Histogram equalization is one of the many image enhancement techniques. The upper left image shows haze image due to low contrast. Upper right graph is the histogram of a left image. X-axis is intensity from 0 to 255, and y-axis is a number of pixels. Number of pixels with the corresponding intensity. This graph shows the range of the histogram from here to here is narrow, and there is no pixels with dark and bright intensity. However, by modifying the histogram with the equalization hist subroutine, then the range become from here to here, from 0 to 255. They use a full range of intensity. Then we can get the image with a high contrast. The black and the white is over here, so we can modify from this original image to better contrast image. The subroutine in Paint can remove the damage to images. In this case, there is some word over the original picture. Then in Paint can remove the unnecessary text on the image. Morphological operation includes erosion and dilatation and opening and closing. The erosion and dilatation can be defined as follows. Erosion of A by B means the structure B travels inside A, cutting off the part where the B's center does not pass. Dilatation of A by B means the structure B travels outside of A, including the parts at the center of B. This picture shows the result of erosion of this original image, and you can see the blade of the windmill becomes darker. It was eroded here, and this image is a result of a dilatation of image 1. Then you can hardly see the blade of the windmill. So this is a dilatation. The opening can be achieved by applying the erosion first, then by applying dilatation later. The closing can be achieved by applying dilatation first, then applying erosion later. OpenCV provides several morphological operation subroutines. Distance transform and flood fill can also be used. Distance transform calculates the distance from the object boundary and indicate the distance to the image. Flood fill can be used to fill a hole in an image. When a seed is given, the pixel near the seed with similar intensity are merged together. On the background of Mona Lisa, here is a seed. Then the background can be merged together. So this background are merged together. Thresholding is to make a binary image from a grayscale image by cutting off pixels whose intensity value are above the specific threshold value and assigning the white value. And the rest of pixels are assigned to be black. This is a source image. If we draw the histogram, the black pixels are over here, and the gray pixels and the white pixels are here. So by cutting from here, this is threshold value. So if we cut here, all the pixels above this threshold value should be assigned to 255, the white value. The pixels below this thresholding value is assigned to 0, the black. So the result of thresholding is a black and white image. The binary thresholding, we can get this image, but there is some error over here. So that's because this area that can be black or they can be white. So by applying adaptive binary threshold, we can get the whole checkerboard image over here. So instead applying only one threshold value, we can apply this linear value, or we thresholding this area and this area, or thresholding this area and this area, and truncated thresholding value, and we can apply the several different methods to get the best result out of the source image to get the best binary image. This slide shows a watershed subroutine that is a kind of segmentation routine. In the grayscale image, you can see the part with a high pixel value as a hill and the part with a low pixel value as a valley. This is valley, and here valley, and here. So this is a low pixel, low intensity. This is a high intensity. So if we assign the different color water, this is a red, and this is blue. Here green. When we increase the water level, then at some point the water can be flooded. So in order not to flood it and to prevent mixing, prevent the mixed up between red and the blue water, we should build a fence like this. So up to here, so we create another fence here. Then finally we can get the red water here, blue water here, and green water here. So that this slide shows the background subtraction. When we have a background image and the hand image on the background image, we can get the hand image segmented from the background by applying background subtractor subroutine. Background subtractor. Then we can get the hand image that is segmented from the background. This slide shows the function of a grab cut. So here is a robot, and I think he is Gary Bradesky. So by applying the grab cut, so we can segment the robot and segment the Bradesky. It is a very successful result of segmentation. Another segmentation technique called motion template is also provided. When an object silhouette is achieved here, and some part of body is moving, this arm is moving, so this image is called motion history image, MHI. And based on that human history image, the motion history gradients image are calculated like this. Then the motion segmentation algorithm applied using these images. Using update motion history and calc motion gradient and calc global orientation, so motion can be segmented and the pose can be recognized. I assume that there was a movie over here, so we cannot get the movie over here. But based on motion, we can calculate the pose and we can do the segmentation. You might be familiar with the shooting game like this. This is gun and this is a labyrinth. And here camera captures the head face of the gamer, and the camera captures the motion of your head and control the game based on the motion of your head. So OpenCV provide cam shift subroutine to control the game with operator's head. The POSIT can estimate the translation X and Y and Z translation and the rotation vector between the cameras and the model's coordinate system. So this is a model of airplane, and they estimate the roll, yaw, tilt, the pose of this airplane, and the green dot is back projected based on the estimated transformation information. So it is quite similar to the rear and the estimated position. The yellow one is rear position, and the green dot is estimated pose of this airplane. OpenCV can transform a given original image in a variety of ways. The affine transformation can be transformed into parallelogram when the original image is rectangular, and can be transformed to increase the length or rotate it. So we can enlarge this original image, and we can rotate that image, or we increase the length of one side, and this is a parallelogram, 평행사변형 in Korean. So affine transformation make this kind of transformation, and perspective transform, also called homography. So can transform a rectangular image into trapezoid. Trapezoid is a 사다리꼴. So in perspective transformation can transform like this. So this is original image of buffalo, and in using perspective transformation we can transform like this, and this is affine transformation, rotation and scale, affine warp, affine scale. So based on the transformed image, we can get the transformation matrix to use get affine transform, get perspective transform, or we can transform the image using affine warp affine, warp perspective. Homography maps one plane to another. In computer vision application, a plane in the world to the camera plane. So this is object plane in 3D world, and this is image plane. In the picture below, there is a chessboard plane that is used to calibrate the camera, and there is another plane in the camera image plane. We can transform the coordinates of the points on the chessboard plane into the coordinates of the corresponding images using a fine transformation. We will study deeper when we study on the camera calibration with a lecture note of Robert Collins. OpenCV provide find homography and get a perspective transform routine to get the transformation matrix. Camera calibration can be done by holding checkerboard in front of camera for a few seconds. Then the corner of the rectangles, this one, are detected and the pose of a checkerboard is calculated. So after calculating the pose, the checkerboard is placed in the virtual 3D space. This routine is repeated several times, and finally OpenCV calculates the camera parameter such as lens distortion, lens center, focal length. And using this parameter, the distorted image can be corrected into undistorted image. So this is a distorted image, and when we get the undistorted image, this one should be here, this one should be straight line, and yes. The stereo camera are used to achieve the depth information from the images. If there are two perfectly aligned camera image plane, this one and this one, and we can get the image of a point P. This is a point P, and this is image on left camera, and this is image of a right camera. And by analyzing the two images of point P on both camera, the depth Z from here to here, this is Z, depth information can be achieved, calculated. This depth information is calculated based on the disparity. D is disparity. Disparity is difference between the image location on of the left camera and the right camera. So XL minus XR. So when object is near to the camera, the disparity become bigger, and P is moving away, the disparity become smaller. So nearer object at the object in the near, and the object at far away from the camera have this different disparity. This is a disparity, and this calculated the distance G. So as the disparity becomes smaller, a distance become larger, and when this disparity become bigger, and the distance Z become smaller. We can get the depth value from this equation. So Z equal FT over XL and minus R. This is disparity. So T is a distance between the origin of this camera. F equal focal length from here to here. But it is impossible to get perfectly aligned image plane. Thus, we need to make a mathematical model that include parameters for possible misalignment. This angle and some error in between this distance. So we need to put this parameter in the mathematical equation. Then using calibration routine, we can get the parameter values. The stereo rectification algorithm steps are shown at right. This is a algorithm. First, camera calibration for each camera is performed to get the undistorted image. Left camera and the right camera, each camera should be calibrated, and this distorted line should be straightened. This is undistorted image. Then rectify. So by calibrating stereo camera, so we set the same height for corresponding points. For example, at the original image, this point and this point is not at the same height, right? After rectification, this point and this point are at the same height. That is a result of rectification. So after we rectify the stereo images, then we can easily get the corresponding point, and we calculate the disparity. Then we can get depth information. Machine learning algorithms are included in OpenCV. The DNN class includes the Deep Learning Neural Network module, and the ML class includes Machine Learning module, and the FLANN class includes the FAST library for Approximate Nearest Neighbor module. If you want to develop a machine learning program using OpenCV module, please visit manual and tutorial on this library. This is some project idea. The author of this document says, feel free to steal, modify, or ignore. So this is some example of a project. So I suggest that you should suggest some term project topic, and you need to find the topic related to the machine vision, and define the system, and the objective of system, and the related technology, such as OpenCV subroutines, and draw image. For example, this is a camera and some object, and 3D sketch is included. So this is the homework for the first homework for you, and this should due date of this homework is by next Monday. The detailed description of this homework I will posted it on the e-class. Okay, bye bye.